out what I needed to do, make sure that they were properly anonymized and met all the standard requirements. Those are the proper releases, but you follow like 8 rules. So I jumped through all the hoops and dot the I's and cross the T's, and we're good to go.
Welcome to the Brain Bar.
Yeah, it's gonna be fun. It won't be boring.
You want to test the screen sharing, see if it works? Hit the little plus sign at the bottom.
Yeah, I should probably pull something up. There's a ton of stuff I could show. It's like, well, what do I show? Well, let's pull. Hold on, pull something like this up. Okay, now that this is up, I'm going to downsize this. I don't want to spoil anything. Push the screen share.
Don't spoil it for me. I don't know what I'm looking at.
Well, I mean, I labeled them so I know which one I'm opening, but don't want to spoil it to the audience. So share slides. I think share entire screen. Let's see how that works. I've got lots of screens, so I've got to pick the exact window. There we go. You should see WinEEG now. Do you see it?
Let's see. I see this. Add to stage.
Do you see?
I see.
Yeah, I see it. So I can pull. I'll put this on the side. What I'm going to do is I'm going to put you over in the corner over here. I've got more than one monitor running. I've got you over here, and then I've got what I'm doing on the screen right here. So yeah, you should. If everyone sees it now, it's live. We got Brainwaves.
Joshua, tell everybody what we think we're doing. What I think we're doing is we've been doing this Q&A for a while, and it takes a little while for people to get back from work and get to the computers, and we got a little lull. So we said, hey, let's pull up a recording, take a look at it, nerd out on it, and then we're going to test Jay in the morning and say, hey, Jay, this is what we got. What do you think? And he's going to play Karnak from The Tonight Show and Johnny Carson.
Yes.
And say, I think, and then boom. Is that your understanding, sir?
Yeah, I think so. Yeah. Yeah. So what we're going to do during our hour, where we're going to look at them and talk about them. I know Jay does the Karnak thing, which is great. There's no problem there.
Oh, right.
Do you want us to look at it today?
We're just going to pull it up and you point, you talk, and just like at the bar when people show up, they may come in and ask questions like Anthony. Yeah. JD,
my only concern is I'll recognize the cases, so I'll know too much about them already. Even though there's hundreds of them, I generally will recognize them.
We have Dr. Mitchell from New Zealand here. Hi, Jay and Anthony. We'll pass it on to Jay in the morning.
Sure. Dr. Mitchell, head from New Zealand. Yeah, great.
I wonder what time it is in New Zealand.
That's a good question. Seems like a question for
Dr. Mitchell. What time is it there?
Not a human. All right, and he answers.
Yeah, morning or something.
4 p.m. our time over here.
Oh, 12 p.m. Okay.
Okay.
Thanks for joining us, sir. Oh, it's Thursday already. That's wild.
Yeah. So it's a Thursday on a different, so 12 p.m. on a different day. Yeah.
That's like 18 hours.
Well, I've had those weird moments that are sort of like theoretical, but I've had those weird moments where you depart from one country on a day and you arrive the day before. Like I've actually done weird stuff like that because I've traveled a lot, and just weird. Or seeing the sunset twice in one day. It's just like messing with your head a little bit.
Or if you leave for like going over there and then you come back, it's like you only spent an hour, but you were gone like 24 or something like that. Isn't that crazy?
Yeah. Or the eternal sunset that lasted like, 12 hours. Just like eternal twilight. Love it.
Well,
great.
Throw it up. What do we got?
Yeah, so I'll throw up some brainwaves. Hold on. Let's see here. Gotta make sure I have the right kind of case I want to send you guys.
No problem.
Okay. And then I'm getting practiced at some of the mechanics here. Share screen. We're going to choose window, WinEEG. Perfect. So this is kind of what we got going. It is, these are our brainwaves. So the question is, what do y'all want to talk about?
What are we looking at, Dr. Mitchell?
Well, he might know. It's a question that people like. Do people even read this kind of stuff? Which I hope they do, but I don't know if they do. This is what I read primarily. Mm-hmm. But there's a common trend for people to use like automation, and I'm not a huge fan of it. Mm-hmm.
Anthony, welcome to the Brain Bar. Belly up to the bar. I'm your bartender, Pete.
You made it.
One hot chocolate coming up.
These are already cleaned, by the way. One thing we didn't get to discuss before kind of launching this program is, do you want them to be uncleaned or cleaned? These ones are a little bit messy, but they're more clean than not. So like we haven't de-artifacted some of these things. We could pull out, we can pull out some of the muscle. You could do this. We could flag a bunch of stuff, take it out.
Please,
it's not going to add up a lot anyways.
Please keep in the jaw tension, please.
Yeah, it's actually like left eye tension too. Yeah. Oh, yeah, it's jaw tension. Yeah, you're right. Left jaw and left temple. Kind of a left. Whenever you see muscle tension that's really like one-sided, you wonder if there's a story there. Because people don't usually create unilateral muscle tension. Sometimes if they get hit pretty hard, or if there's, like when you're bracing, you tend to move to the right. Most people do, not everybody does, but you get some sort of like almost permanent bracing from some incidences where you'll get unilateral tension, almost like a wincing type response. It's interesting. It's not taking it all out, and it's also extremely persistent. There's probably a reason why I didn't take it out originally. It may have been too much, or maybe it didn't de-artifact well. And it's also not necessarily related. Like if you're looking at like a lot of beta spindles, separating the muscle tension can be really important. But if you're not looking at a lot of high frequency content, then you can just kind of ignore the muscle tension. It'll average up, but you can just ignore it.
Anthony, how's it looking on your end? Because I know these squigglies here, it can be a little.
So it's definitely easier to read on a large laptop screen.
Oh, yeah.
Fair enough. Yeah.
You have to expand the video, by the way. So,
Yeah. Yeah. So it's not full screen for you guys. I wonder if I could. I'm curious if I can make it full screen. I'm gonna play with it. We're doing the tinkering stage. So you guys can. By the way, there's a button. There's a button you can push to make it full screen.
No, I can see full screen. Yeah.
Okay. Cool. Gotcha.
More or less. I mean, I see the three of us on the left. Yeah.
I'm just saying, everybody on their end, they got to tweak, use your cloud or whatever, figure it out. But this is about as big as they'll let us do, I think. Unless
there are a little bit of beta spindles in here that look real. So maybe it's appropriate to keep some of the muscle tension edited out. I don't know. Hard to say.
I took the talking heads out of it. Is it better this way, Dr. Mitchell? You tell me. That's the option. You got this option. You got this option. You got this.
Oh, hello. Love it.
So, Josh, why would you leave? Because is it still good to suppress muscle tension? Would that be advisable?
Well, let's look at this without any kind of editing. We can always open it back up. But let's go all the way back and just see what it looked like before I edited anything. So maybe I should have taken out the muscle tension, or maybe I just couldn't get it all out because there's too much. We can go find out in a minute. We're going to clear this. Clear it all. So we're looking at de-artifacting now. So people are learning. If you get a recording like this, it's not unusual. There's all kinds of reasons why. You can see there's a lot more muscle tension going on. And we can take it out using Mark Artifact, which is fast Fourier software that will do independent component analysis for, intended for artifact. So we should be able to, throw out some of the muscle tension. Give it a minute to process. And let's see if we can get out all of it. Maybe we can do a better job than I did. Like, who knows how long ago it was that I actually de-artifacted this. Maybe we can do it. Yeah, because it definitely was some left side that we didn't finish up on. I can be a little light-handed on de-artifacting compared to other people. And I'm not advocating for being light-handed. It's just what I tend to do. I just want to see it clearly. I don't necessarily need to get everything out. Because if I notice it's there, I'll just ignore it when the data is averaged up and spectra. When it's all turned into a spectra, I'll just ignore what I know is not real. Other people like to get everything out. It's like, that's fine too.
Yeah.
You have to kind of make a mental note of what you may have taken out. If it takes out real brainwaves, you're making a different kind of mental note. And you can see the first component that it grabs, which is auto-selected. It happens to be brainwaves, which sometimes happens. Don't just accept the auto-select. So right side muscle tension, we got back left, that's our T5 right there. So we got some of the muscle tension out except for T3. T3 is going to be right down here. We still have our front. So we have everything but the frontal lobe. Frontal lobe is going to be, this is our sarcadic eye moment right here, the second one. It does get sarcadic eye, it gets some muscle tension in it as well. But we have lateral left eye tension, lateral right eye tension. So yeah, we probably could have taken more out, but that's looking a lot better, isn't it? Yeah, that looks a lot better. There's still a lot of muscle in there. Like you can see that there's a lot on the back of the head. I don't know if it's worth trying to take out. This looks sort of like a lateral movement of some kind. It's very, very subtle though. But we can take that out as well. You're starting to see that like F7 gets a little flattened out, which is kind of why I tend to be a little bit more light-handed. I think we have a slight muted effect from all those muscle tension we grabbed out, just kind of squashed one channel that may not actually be that flat in reality. But it's probably better than what I had done before. So there, that's it. Does that look better? Yeah, I think so. So any hunches as to what we're looking at here?
What were the symptoms?
Oh man, that's gonna give away the we can totally do it though.
Sorry.
No, you're good. You're good.
Do it your way first, Josh. Yeah.
Well,
I tend to look at like peak alpha frequency, and you'll realize really quickly this person's like 10 and a half, probably maybe 11 at the most. So no issues there. And this is eyes closed for people who don't know. And the second thing you're going to look at is like symmetry. And a lot of people have a hard time seeing symmetry just in the raw data, but you get it with practice. You start to look at like P3, P4, T6 to T5, and you start to realize just by scanning that it's not symmetrical. And like when you look at like P4 and P3, you can actually drag them over each other, and you see that P4 is notably larger, and T6 is significantly larger. Even though it's quieter, T5 is like flat, and T6 is got some consistent content, and T5 rarely does have any. So there's this notable asymmetry with alpha weighted to the right side in T4 and T6. Usually that's incredibly specific to symptomology. It's
hey, Josh, one sec. Hey, Jayhan, are you saying that we got to zoom in more? Because I'm showing a full screen on my end.
No, that's important. We got to figure that out.
Carl says still didn't see the pop-up for the ICA. If you're watching this on the phone, I don't think anything is going to help you.
Yeah. Well, that's the interesting thing. Like when I do classes, I actually will zoom in to part of the data. So like maybe what Jayhan's, and I wish I could draw on the screen, but maybe Jayhan would like to zoom in on like 4 channels, which is kind of what I'll do when I teach sometimes, because you really, really want to get a closer look than just like, if you're on a tablet or a screen, or you're just not on a big computer screen, or you just want a closer look. I could see that request being a valid request. I don't know if we can zoom in larger than life, which might be the request in this software, but it's something you have to do kind of in editing, which is reasonable in editing, by the way. So you're kind of stuck just kind of appreciating it from more of a normal screen. And if you're on a phone, that's not going to work, as Pete said. So I wonder if the asymmetry is kind of evident to most people or not.
There's a lot more activity in those lines, so to speak.
Yeah. Sometimes it's not as bad, but occasionally you'll see like P4, these larger bursts, like they're just undeniably a lot larger. So, and I'm curious if anybody knows the research on that particular asymmetry. Do you know it, Anthony? It's okay if you don't.
Are you referring to the T6 and PTSD research?
Yep. Hypervigilance and reactivity specifically. And I think the frontiers of neuropsychiatry does actually go as far as to call it a neuromarker for PTSD or trauma, which I tend to call it a hypervigilant and reactive finding, which is a little bit more maybe accurate, because there are a few other things that can cause the asymmetry. And when it's caused for some other reason, it's still going to present with hypervigilance and reactivity. So if you get this from a bonk on the head, you're going to have like a coup contra coup. You're going to have some indication that maybe there was an event that took place that caused this that was physical. But the symptoms are going to be the symptoms nonetheless. If you have this alpha asymmetry, they're going to be hypervigilant, they're going to be reactive. And so that language specifically makes you look really, really, really good as a provider, because you can kind of pull a rabbit out of the hat, because there's lots and lots of broad things in the brain that don't tell you anything super specific. But some of these things do get a little specific in that they'll say like what the experience is. It doesn't necessarily tell you why. And the why is often trauma, emotional trauma, but not always. Maybe it might be worth making a mental note. There's a bit of mu here. It's not a lot, but there's a bit of mu. C3, C4, we've got this sort of round on one side, sharp on the other side, kind of wicket fence-like rhythm here. It just shows up for half a second, or maybe a second if you're looking closely, but then it disappears. That's oftentimes an indication that the frontal lobe could function a little bit better. It's a social disconnection, right side emotional, affect, left side language.
Jahan says, looks like the top is front of the head, bottom is the back of the head.
Top is the front of the head. Yeah. Oh, great. So that's why we have audiences, because I take some things for granted. Yeah. So the top, the way it's montaged is that, yeah, we have the first couple of sensors, FP1, FP2, are right above the eyes. And then as we go down, we're actually going left and right, and then eventually further back. And odd numbers on the left, even numbers on the right. And when we get all the way down, you get to the midline right here at CZ. This is the central Z line. So it's literally the top of the head. You go further down and you start moving towards the back of the head. 01, 02 are right on the back of the head in the occiput. And they're about the same distance apart as the eyes are, right on the hat band. It's like FP1, FP2, but on the other side of the head. So it kind of works its way backwards. So good observation and good reminder. And this is an average weight montage, which is in that it will be an extrapolation of, what is average weighted from the sensors around each sensor, which means that we've sort of mathematically, removed the linked ears, which you do need to do about 50 to 60% of the time because of some sort of contamination. So you'll get some sort of data contamination in the reference, and it can erase things that shouldn't be erased, and then it can broadcast things that shouldn't be broadcasted. So sometimes you end up with an alternative one. There's a bit of beta, fast beta. That's interesting. We might see if that averages up. It looks like a little bit more F4 than F3, and it looks very fast. I'd have to fuss over that to see if that's real. What I would do if I had more time is I might actually open up the original file and look at it unartifacted to see if this is sort of a remnant of the artifact, or if this does stand alone looking more like regular beta. So when you have this mismatched muscle tension, people do tend to produce more muscle artifact, but you can also conflate the muscle artifact for beta. So you have to just be more careful.
Jahan wants to know, how does average weight compare to Laplacian?
So Laplacian, I believe, is lateral. I believe we can go find out. We could actually literally switch it. I don't remember which one of these is. I have a double banana manually programmed in here, but I believe double banana is front to back comparison, and I believe Laplacian is like left to right comparison. And so you're going to get a sequential montage, meaning that you're getting brainwaves minused against brainwaves. And it's going to make things that are out of phase really, really, really large. Like if they're completely out of phase and the same amplitude, which is an unfair overgeneralization, but that would present as double the size that it actually is, which is not bad. It's just representing it differently. The things that are absolutely in phase are going to actually maybe be averaged out or suppressed. They're going to be suppressed. So if you have content in the lateral channels that are identical, those can actually get suppressed and muted. And so because of that, there's a few things to consider. One, average weight is kind of determined by the most amount of people and published to be maybe one of the more reliable montages. And despite that, you should probably look at the data in three different montages. So it's like, check the linked years, check the average weight, maybe check the Laplacian, maybe check the double banana, you know. And there's a few others that people do like. So it's like, there's a few more. There's a run of mu here, so the mu does come up more often. And it seems to come up after the beta shows up. If this is real beta, maybe it's triggered by the beta. Because sometimes you'll see something happen in sequence where something in the frontal lobe will occur, and then the mu will start to idle because it's a secondary response, not a primary response to a frontal lobe function. So when you see mu, you start to go, well, what's going on in the frontal lobe? And we aggressively de-artifact. That might have been why I didn't aggressively de-artifact, by the way, because I knew I didn't take out all that muscle probably for a reason, and I haven't had time to fuss over it and figure out what I was thinking. It's probably that I saw this beta, thought that it was real, and then went and reduced the amount of de-artifacting I did so that I could get a better look at this. That's probably what was going on. And we can still see enough of it to kind of piece together what I was probably thinking. So
Carl says Laplacian would make things like mu more obvious, just like you said, Derek.
Sure. Yeah, fair enough. Yeah, different things pop out more with different montages. I know that like neurologists, they like their double banana. Laplacian's pretty popular in the qEEG circles for good reason. Yeah, so let's take a look at this. We've kind of been looking at, we know there's mu, we know that there's some frontal, we think there's some frontal beta. I wouldn't say with absolute confidence. We do see some alpha asymmetry. So there we go. So there it is. When you get an alpha asymmetry that's, you know, it doesn't have to be 50% higher on the right-hand side. But if it does cross that line, you know you're going to have hypervigilance and reactivity specific to P4 and T6. So, you know, they've got a reasonable peak. I said it was going to be like 11. Yeah, it's about 11. So maybe 10.5, 11, and it's 11. It's pretty lean to the right side. On this software, you can go to maps of asymmetry. And over here on the right-hand side, where it says 100, if you can scroll it to 50 and it hits purple, then you're notably over 50%. And they are. And it even looks like it bridges up into the temporal ranges. And that makes you wonder if they were capable or they are capable of dissociation. There's a few ways to tell. We can look at that in a bit. Part of me wants to look at the beta. Or look at this. What do you see here?
Pretty colors.
Pretty colors. So we do have that F4 31 hertz. That's probably a glutamate finding, which is to say that their brain is sort of not removing glutamate properly. I don't understand that completely. It's not an area of expertise of mine, but it usually means that they need some support, sensory motor rhythm training. It might be that there was an incident or accident or something that could precipitate that. So that beta at 31 hertz is sometimes specific to a failure to modulate glutamate. That's what we were seeing, I think. So it looks real, but we can actually kind of tell if they might be dissociative. We're going to go to analysis, independent component spectra, full 4 seconds. We'll take 12 components. This is using ICA again, but instead of doing it to de-artifact the software, we're going to use it to actually pull out brainwave components and analyze brainwave components. And what I'd like to do is I'd like to see how that right side alpha interacts with the frontal lobe. And if it does interact at all with the right insula, it's probable that they are capable of dissociating. So that's some newer theory. So you can grab component 1, go to the sLORETA for components here, and it will give you some 3D maps. The WinEEG doesn't really come with this, but it's free. You can have it installed for free, but it takes a little bit more work to get it. So first component, we don't really see it hitting the insula, which is this C-shaped component right here in the frontal lobe. It gets pretty close, but it doesn't hit it. Jay knows a lot more about this anatomy than I do, so he'll go over it in greater detail. We can look at another component. I kind of go down the list of the components and look at them one by one.
What is this add-on you say you're using here?
This right here is sLORETA.
Oh, okay. Yeah.
And sLORETA is something that you can essentially email. You can download for free, and you can email the producers and ask for a key. And generally, they'll let you have it if you're like a provider or a researcher or licensed or under supervision. They'll ask you a question or two, and then they'll let you have it generally. Yeah, which is really cool.
So they don't have the right insula finding.
Oh yeah, hold on. Carl's right. I don't see. We're not seeing the recording. We see the pretty colors on the left, but we don't see anything in the middle.
Well, there's nothing in the middle. I'm trying to open it. The software's being a little bit glitchy. You don't have that many time frames. Try again. So it looks like it can't load LORETA for some of these things. I'm not entirely sure why, but it doesn't want to. So do you see it? Oh, you don't. Oh, you don't see it. Oh, I see it. You don't. Hold on. Let me stop sharing. I see what's going on here.
Interesting.
I'm going to see. I need to share my whole screen, not just the software, because it doesn't consider the LORETA the same software. That's comedic. We're learning new things. This is why we're doing all this. I'm going to share the entire screen. There we go. Okay, this should do it. This should do it. Okay, now you should be able to see it. Okay, back to it. Okay, good catch, by the way. So what I did was I basically loaded this component and put
LORETA. We still got the white. Oh wait. Oh,
yeah,
there we go.
So I figured it out. So we're learning. We're finding our groove. We've not done this before.
It's
it turns out
feedback.
I can't share the application with EEG. I have to share my entire screen because the LORETA is actually a different software technically, according to your streaming app. It thinks it's a different software, which it probably is. You have to download it separately and then kind of merge it, I think. But I was kind of looking at how close the right side finding creeps up to the insula here. It's this C-shaped component right here.
And do you want to explain?
Yeah, go ahead.
Do you want to explain for people why you're so what do you consider dissociation, and why are you interested in knowing that answer?
Well, it's good. They'll be able to tell you probably, but it's very validating. And I would say that with trauma, being able to validate someone's symptoms with an image brings a huge amount of containment and trust. And when you're doing trauma therapy, you're going to need that as a resource. You're going to need that rapport. And so, just kind of walking through this with people and saying like, oh, I can see that you struggle with hypervigilance and reactivity. That can look like being triggered. That can be looking like flashbacks. That can look like nightmares. And they're going to nod in very strong agreement. They're going to have this big nodding along. And so then when you go ahead.
Is that what you're calling dissociation? Is triggering and flashback? Or I just want to...
No. That's just the right side asymmetry. But you will find components that will...
okay, you mean this is an EEG term of dissociation. You don't mean like a clinical psychology type of thing, or you do?
No, I mean a clinical dissociation. Like they're capable of fight, flight, or freeze.
Okay.
So I don't know that this particular person was capable of dissociation in the classic sense. They got kind of close to it, and they still could. But if you had someone whose main complaint was dissociation, typically the alpha component will either pop into the insula or will creep up on the insula in a much more aggressive way. And right now we don't see it quite. It doesn't quite hit the insula. It doesn't cozy up next to it or get into the C-shaped component right here. And if it did, then you could kind of predict pretty accurately that they're going to present with some fight, flight, or freeze issues. And you can have that disruption of the insula with those symptoms and it not be trauma. But when you have this trauma neuromarker, and it's bad enough, sometimes it'll creep into the right insula, and that's going to be associated with the trauma, and it's going to trigger the fight, flight, or freeze. The right insula is responsible for regulating parasympathetic, and when it's disrupted, like with this alpha, you'll lock into parasympathetic, and you'll do so without any sympathetic drive. And so, no sympathetic drive plus maximum parasympathetic equals dissociation. And you can see that through biometrics. And if Saul were here, he'd be talking all about it, I suspect. Because you can watch somebody, they'll have like no galsonic skin response variables. They'll be like low numbers on galsonic skin response, super high heart rate variability. And that's when they're locked into the right insula, and the parasympathetic is locked on. So it's not properly compensating for anything. It's just locked on. And and again, that can be experienced a number of different ways. But with trauma, it usually looks like a freeze or a fawn, or some sort of freeze or fawn type or flight.
And you said
less fight, more fawn and freeze.
And you said the insula gets locked on. I'm trying to, because I know we use that term for the ACC a lot, but go on.
Well, when I say locked on, it might be the wrong semantics. It gets locked in that it doesn't properly regulate.
Thank you.
Parasympathetic. So
yeah, I just want to make sure I'm understanding, so I appreciate it. Yes.
No, it's a very, very good question. Very, very good question. It doesn't properly regulate parasympathetic, and the result is that parasympathetic gets locked on. And we see similar things with the left insula, but it relates to sympathetic drive.
Wow.
So I'm a migrainer, and mine are a little bit more left than right. And when I have like a tension headache or a light migraine, I'm just hyper productive because I'm like locked into sympathetic drive.
Wow.
Some people are agitated and annoying, and when I have a really bad migraine, I'm kind of a jerk.
That's a shame. But yeah,
my wife gets me though. She's like, bless her heart,
yeah.
So that's kind of a little bit of a classic PTSD. There's something else going on here where maybe there was some. You could almost wonder if there's some. You'd ask about physical abuse because there's some excess glutamate buildup. At least we suspect that based off of the 31 hertz finding. It looks more like emotional trauma than physical trauma, but there's still some evidence of some physical event nonetheless. It's not a coup contra coup like in a concussion, but there is something else going on there. So
wow,
you can kind of see the high frequency behavior. If you zoom way in, you can see this little 31 hertz build up right here.
Wow.
Yeah.
And that's not part of like, I know benzo bump is lower, but that wouldn't be, there's no other causes of something like that are common or?
I mean, I think I need to ask and get some clarification from Jay. If the 31 hertz is the same thing as Harry Karadicides' research on BAMA, which he kind of was an affectionate nickname for a type of gamma that's from being bonked around and not a healthy type of gamma.
Yeah.
So
we got a drink order in, Anthony. You got
had my phone. Josh, my font is on the laptop. You do
is excess glutamate just a high beta thing, or is it connected to mid and low beta too?
It's not connected to low beta or mid beta. Low beta is strongly oriented towards compensation and stabilization, especially along the sensory motor strip. Mid beta is more performance driven. It can be based on task and memory, that kind of thing, and it keeps people more engaged and active and oriented. So it's more excitatory, but still more stabilizing and function driven. And then once you get above 18 to 20 hertz, it tends to be more problematic than good. There's different research to suggest that maybe it's a maladaptation run amok, maybe it's a failure mode. The reality is probably both in different ways and different people for different reasons. And then you cross like the 30 hertz barrier into like 31, 32 hertz, and you're starting to bridge into like gamma type ranges. And there's multiple types of gamma. You've got chirping gamma, which is healthy gamma, and it's usually nestled in theta and alpha, and it does chirp, and it's usually got like 7 little spindles for the average person, which correlates perfectly with the cognitive test digit span, your ability to hold 7 numbers in your head. There's all kinds of cool data around it. But then you have things like tonic gamma, which you see in disease, and you'll see it widespread and global in Parkinson's and Alzheimer's. And then you'll see sort of regional sort of gamma-like findings that are coupled with tonic theta in injuries, which is sort of a dysrhythmia. So, and they may all be kind of related, and I'm kind of waiting to see this kind of consolidate in my own mind and my own understanding. Maybe this is understood, or maybe it's being understood as we speak. It's kind of coming together.
Drink order. Josh, are you describing a kind of migraines without the classic auras like light, smells, headache, etc., when do you think about migraines? Are there EEG findings?
Yeah, it's not I could show you my brain waves and you could look at migraines all day. Migraines, there's probably a few different types. Some of them can look like this, but many of them are going to look like vascular ischemia, and that's going to be your vascular ischemic migraines, which is going to look like alpha that, as it gets slow, diffuses laterally into T5 and T3. And the slow edge of alpha will diffuse laterally. And that's one way that you understand that it's an ischemic finding, and generally can be easily associated with migraines. When you often see bilateral sharp slow transients, these are like sharp and slow, or sometimes sinusoidal content that's out of phase left to right, but in phase front to back. That's the opposite of alpha, just to make a mental note. That content is often accompanying the lateralized slow alpha. And that's those two features together oftentimes what make you pull out, the question, hey, do you suffer from pounding migraines? And a lot of the time they'll say yes.
Now, we associate, I believe migraines are associated very often with muscle tension. Is there like a differential, or that's just a downstream effect?
Well,
or something?
I think it's both. But I also think that, you could say more accurately and more correctly more often that headaches are associated with muscle tension.
Got it.
And that semantically is far, far, far more accurate.
Yeah.
And that they could even be caused by the muscle tension. Muscle tension will interact with migraines. They might even trigger a migraine, but for most people, they're genetic rather than acquired. They can be acquired, but they're most of the time just genetic.
Wow.
So if muscle tension isn't the primary cause, you have a primary genetic cause in most cases. It can be acquired from injury, but I think most people it's going to be genetic.
Yeah, that reminds me of the quote though from last week it was something to the effect of all of the spindles and paroxysms stem from slow waves ultimately. And I don't know how true that was or the bounds of that, but it's reminding me.
Can you say that one more time?
That all paroxysmal activity ultimately is stemming from slow wave issues. So like alpha and below is the gist. That's what I got. And I don't remember where I heard or read that. It might've been on here, but anyway.
It's interesting. Yeah.
It would be in my
you mean that the paroxysms are content from the thalamocortical loop?
It might have just been about epilepsy, but I feel like when we get into subclinical epilepsy, there's kind of a subjective gray area there.
I usually see sharp slow content preceding a paroxysm. You don't always see it, but you usually can find some little hidden, sharp slow transient right before the preceding paroxysm. That's kind of how I understood it. But I always thought of it as an unstable state change. But I wouldn't be surprised if it was related to some thalamocortical loop.
I feel like we got into this or touched on it that you said something to the effect that I have in my notes here that alpha is a source of seizures and topiramate can address it.
Well, I don't know if alpha is the source of those instabilities. I know that topiramate reduces the alpha peak. But it's also an anticonvulsant, so you're going to reduce sharp slow transients. It's not a favorite for seizures. It is more of a favorite for migraineurs.
Well, I don't want to derail too much if there's other questions or anything. But
Anthony, read. We got a drink order from Sisyphus.
Oh, awesome!
Let's see here. Yeah, what is this live about? Could I ask questions about brainwaves? Trying to learn more about focus states. Yeah, I'll let Pete address that if he can ask questions. But they're reading an EEG live on air, Sisyphus. Yeah. So go on, you guys. What do you think?
Yeah, focus states. I mean, there's a lot of things that we could talk about when it comes to focus states. I understand maybe more primarily the vigilance model. So we can go all the way back to the beginning. And you can see, okay, I wish I could draw on this, because if I draw on this, I'd actually maybe be useful. But you can see that there's alpha at 0102. Primarily, when we're first starting the recording, we asked them to close their eyes. That's where it says EC. And they're doing pretty good. It's waxing and waning. as they kind of go along, occasionally you'll see alpha creep up into like PZ, and sometimes a little bit CZ. We can kind of go until we find it do that. Here we go. Actually, we jumped all the way to A3. So you can see all of a sudden alpha at 17 seconds starts to show up in the frontal lobe. So we kind of went maybe in sort of a covert A1, which is proper vigilance. I'm alert. Alpha's on the back of the head. Alpha can kind of creep up into P3, P4, PZ, maybe CZ a little bit. That's A2. A3 at 17 seconds, alpha goes into the frontal lobe, which you can clearly see. This is like still technically an alert state, but it's like the final alert state prior to drowsiness. The most productive alert state might be like A1. But you do wax and wane quite a bit. We only looked at 20 seconds and we saw A1, A2, A3. And you can get to drowsing too. If we scan this and we go past a few minutes, they're liable to get drowsy at some point. Maybe right here. Here's B1. See, there's no alpha. Well, their eyes are still closed. Where's all the alpha? Well, they're not in a hypervigilance state. They're actually starting to get drowsy. Alpha drops out at B1. And that's the first stage of drowsing. And then we start to see this kind of slow rolling that occurs, maybe at 218 seconds. We're kind of bridging on what might be B2. I don't know how useful this is for Sisyphus, but this is kind of classic sleep vigilance or alert vigilance states,
Sisyphus says, is it true that when you're in a flow state, gamma waves encode with lower frequency states like delta, theta, and rhythmically flow together so that every second cycle the energy increases? Or?
Let me read it carefully. In your flow state, gamma waves encode with lower frequency states like delta, theta. This is a little bit beyond me, I think, because you're probably talking about like open focus type stuff, which is a little bit before my time. I know a bit about Alpha Theta, which is a little bit bridging on what we're talking about here. I don't actually know, and I don't know if people actually also know for sure. There's probably a lot of maybe content presented by fairly influential people, but I don't know if they really know some of the stuff. Like gamma's hard to study.
Yeah. Well, Sisyphus, just a heads up. We're going to meet with Jay Gunkelman in the morning.
Oh, that's a good idea. I see what he's saying.
He's going to look at this, and I'm going to say, "Hey, we got this question from Sisyphus," and then bam, we will address it there. El Chatterino, welcome, sir. Again. You can always hit print screen and then draw on the snapshot of the traces.
Yeah, I like it. He's not wrong. So we can talk about mu.
Nice.
I like it. I like it a lot. There you go. The man knows things. Thanks,
Good
Ryan. I will use it. It's good advice.
Next drinks on Anthony.
Yep.
Well, I have a Sisyphus question. It's the last question I see here. Oh, I've heard when you meditate, gamma waves pulse inside the lower states, and that what creates the energizing feeling and downloads people get in meditation. So it sounds to me like he's talking about either nesting or synchrony, but of gamma within the slower waves. I'm worried he's talking about tag sync, which guests on this program have not had a high estimation of. We're trying to synchronize all three, I guess, through training. I don't know if you've heard of that, Josh, or
no. I'm kind of ignorant when it comes to gamma. I know only the bare basics. Yeah, and there's probably a whole decade of meditation based neurofeedback that I'm just never got into, never integrated. And it was sort of a different kind of camp than I trained under. And I suspect Jay understands it really well, but he hasn't really taught it. I'm sure he has his reasons. But yeah, it's interesting.
Yeah.
So here's an interesting point.
What was that? Sorry.
Oh, just wanted to point out they're subtle sometimes. This is a way of zooming in on it too. When we look at the frontal lobe, you can see that kind of 31 hertz frequency right there. It's a bit more right than left. That's why it focalizes at F4.
Would gamma be? Chad's talking about would my when I'm on a laptop here, I have trouble seeing the text in the bottom right sometimes.
I got you.
Yeah, go for it. Sorry.
El Chatterino, would gamma be lacing the theta with the timing of the alpha propagation together?
Well, I don't know how the integration between theta and alpha works with gamma. I do suspect there is some interplay. I've always understood gamma to be sort of the answer to the binding problem in classic psychology. That it essentially is like it's what makes you feel a common integrated experience when your actual like sensory motor cortex and auditory cortex and all the other different parts of your brain that are responsible for seeing, hearing, feeling, touching, moving, those all integrate into one experience. But the reality is that data never actually meets up anywhere. It's gamma that ties them all together. And it does so likely across space and time because it's a quantum mechanism. And I know that you're probably going to see research or commentary, whether it's research or commentary does matter. And I don't know which one is which right now. It's a bit murky on how they relate to each other. I think there's a difference between what's commented on and what's fully known, which is kind of why I hold it at a distance. Because I'm really willing to be deeply, deeply wrong, on things that I guess I'd like to dance in a camp where there's a little more certainty. I'm willing to be wrong, but I'd like to dance in a camp where there's a little more certainty. And there's a lot of talk around gamma.
Yeah.
And it's not all useful.
Sisyphus says, what I've learned is gamma isn't a steady state. It just happens for a second and then combines with theta waves to increase amplitude, essentially.
That's what healthy gamma is that I understand, Sisyphus. I believe Josh was touching on that earlier when he was talking about the nesting, 7 sort of spindles. Josh can continue to comment.
Yeah, we could maybe I could draw it or something like that. But generally, from what I understand it, is that you have sort of spindles, or chirps is the technical term, chirps of gamma within theta. So it's within the actual theta hertz. You have a single cycle of theta. There's going to be a chirp of gamma in there or alpha. And that chirp typically has like 6 to 8 spindles. And those spindles can be measured. Anesthesiologists actually have devices that will relate alpha to gamma ratios to tell if you're awake or need more anesthesia. So they can tell if you're waking up long before you actually wake up. So these are medical devices used in hospitals and anesthesia, which is really cool. But you can also look at it, and I believe it's the cognitive test digit span. It's the ability to like maintain a set number of patterns in your head, like a phone number. That's why we have phone numbers with 7 digits. It's because we expect that the average person can remember 7 numbers. And it has to do with having 7 cycles in each gamma chirp. If you have 8, you can generally hold 8 numbers in your head pretty reliably. If you're unfortunate and you have 6, phone numbers are going to be hard. you're gonna hope that they don't give you an area code that's unique. So it's just kind of it's interesting. There's interesting commentary on it, And as I said, I like to stay away from commentary that I'm not sure if it's published reliably or not, because there's so much interesting discussion around it. But I don't know what's reliable or not. So it's difficult.
You know what's cool? Yeah,
Mm-hmm.
go on.
Joshua, we don't know what we don't know. We're getting towards the end of the show here.
Oh, wow. That was fast.
I know. I know. Here, I'm gonna give a little breathing space here. Let me see. Which one do we want? This one? No.
Yeah. Perfect. Move things around here.
We'll go back to the recording, but the problem we've always had with this show is we speak to technicians, we speak to the end users of this, and we try to offer something for everybody. Do you think you could do like a minute or 2 summary of, like, if the mom or dad, you're going to show them the pretty picture, right? And you say, hey, this is what's happening. And then the technician, like Jay, is going to say, show me the raw recording that corresponds to make those pretty colors and kind of just sum up what it is, so I could clip it all together, and then we can do the reveal.
Yeah. So I saw Rita had a question. Was that a question, Pete? I want to make sure I didn't.
I think I got smoked here. Is that a branded Marty McFly life preserver?
Branded from maybe. I know Radar asked what protocols he'd recommend, and I think that's a very functional question.
Okay.
This particular brain map was not the final brain map. I have post brain map showing normalization of alpha frequency, and maybe I should pop that on and show it. But the client did normalize their alpha, and we used either alpha theta or alpha down. I believe in this case, because of the beta spindles, I used alpha down. I don't use alpha theta when there's anything too complicated, anything unstable, anything like 31 hertz findings, anything paroxysmal, anything sharp slow transients. I just don't use alpha theta. Alpha theta is great if there's no other thing going on that could muddy the waters. If there's anything muddying the waters, I tend to try to create a stabilizing fallback protocol, which will be like an SMR-based protocol or an ILF or an ISF protocol. And then I'll use alpha down using Ruth Lannis's research. And it worked really, really well in this case. So the client did great. So
Here, do you want to do the quick shared screen? Just say, look at these pretty colors. So the mom and dad says, ooh.
You want me to pull up the post? Is that what you're saying?
Yeah. Just throw it up one more time.
Yeah.
And just how you would do it. Explain it to a mom and dad, and then how you deal with a technician would look at it. I'm curious.
Well, here's you're sharing. Okay. Let's see if you got it. Do you have the screen? Is it shared? Okay.
And let's do that. Okay.
Oh, perfect. It's shared. Perfect. Okay. This is actually the second one. So if we could actually look at it real quick, this is the client's follow-up, and look at the normalization. You see that alpha asymmetry, how much better it is? I think it was after 12 sessions. It's not extreme. They didn't work crazy hard on it. So when we go to the alpha asymmetry, we got to scroll to 50%. We don't make it. In fact, in order to get to pink, we have to go to 25%. Yeah. So, and they were like this, they were massive, so we reduced the asymmetry huge.
You did it at P4, I'm guessing?
No, PZ, just straight up PZ, alpha down. Ruth Lannis does it eyes open. Too many of my clients have vigilance issues. And so I oftentimes will do eyes closed, but I monitor for drowsiness, and I have really, really good software to monitor for drowsiness. And so I'll try to do eyes closed. I do very, 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 very simple feedback, like boring feedback. It's just beeps. Beep, 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 and they get beeps for suppressing their alpha. And you see a giant alpha rebound, and then they suppress it, and then it rebounds even more. And so generally, you see alpha kind of careening up in this kind of rocking motion when you're training it down. And it'll do that in the very, very first session. I can actually show clinical notes at some point that are redacted and cleaned up because if I have the right releases, because it's fascinating to see how alpha does rebound in the course of a 30-minute session. It's very, very reliable for alpha training. I think Ruth Lannis found that the control group and the placebo groups separated within the first 2 minutes of the first session. So I really like alpha training. It's very easy to get consistent results. I like alpha theta. I find it to be more cathartic, but there's all kinds of cases where you can get trouble when there's these glutamate or gamma or BAMA type findings over here. I don't do anything complicated when you have something like that going on. So
for the mom and dad, are you going to point at that red dot there or the blue? Like, what are you going to do?
Well, when it comes to this kind of the BAMA type gamma-like thing, I'll say, hey, is there a story here? Did something bad happen?
and something fall on their head, like boink.
What's that?
Like something fell on their head, boink. Is that what that red dot is?
Yeah, this is a little bit more. It's probably old. I don't know what the story was. I haven't looked up the case. I don't know the details on it. But usually, maybe they had a bad AFGAR score when they were born, or they were a foster kid and nobody knows, so something, global that was taxing on the nervous system maybe. And the brain is just not that good at, removing this glutamate from the brain, or it could be some dysrhythmia. Usually the location that I'm seeing it at is more common with glutamate.
Yeah. And then on the technician side, what are they going to be saying there? And we'll start wrapping up.
On the technician side?
Yeah, I mean, you would say the people that don't know what they're looking at versus the people that sort of know what they're looking at.
Well, I mean, it's an aberrant frequency that isn't associated with anything positive. You don't know the negative association. I would assume they might train it down. My concern would be that if the nervous system's not really ready to get rid of it, you haven't done enough like stabilizing protocols, like SMR training, you might get side effects from trying to train it down. That's been my experience. You can try, but you better be ready to have your hand slapped.
Okay.
Mm-hmm.
So tomorrow, what do you think? We got about 5 minutes left, Anthony. You wanna ask that, and then let's figure out.
I was going to say, so I noticed that Pete zeroed in on that red dot, but really, I think the first thing you'd be zeroing in on is the big yellow spikes.
Well, so this is normal alpha, and in this case, the asymmetry has been resolved quite a bit. So we're resolving the vast majority of the asymmetry. This is post-training.
Yeah, but
wow.
So I think we missed the part where we got to hear you introduce the parent to the hypervigilance, PTSD, P4T6 findings. So how do you message that? I think it would be nice for people here.
Well, what I do is a little bit more like what Jay does, in that I will maybe do an informed consent intake, but then a week or two later, they come in and do the brain map, and then I have them in my office. And by that point, I've forgotten who they are. And I kind of ask, I ask permission, can I look at the brainwave data before you remind me who you are, before I read your intake paperwork, before I read your assessments? What if we just pulled this up before you remind me? Let's just see what it says, and let me see if I can. Let me see if I can speak, to your experience without basically without checking my notes. And let's see if the brainwaves are enough to tell the story, because they're going to be a mix of broad and specific things. Like and they're always like, yeah, let's do it. And we pull it up, and I'll see something like we saw the first map, not this one, but the first map, and I'll say, this is, when people come in with this alpha asymmetry greater than 50% on the right side, P4, P8, I know that they're complaining about hypervigilance and reactivity. They might have other things going on, but that's going to be a major complaint. Every time you see it, it's going to be a major, major complaint. And so I can kind of I can put my foot down on that one and say, this is why you're here, isn't it? And they'll go, yep. And then you do have to kind of consider all the other side quests that are going on. But there's also the why, what are they complaining of and what do they want? And the side quest might inform your protocol, like it does in this case, where maybe I might do Alpha Theta, but I'm not probably going to do Alpha Theta with somebody who has got a lot of like 31 hertz content, because I feel that I'm going to get side effects. I might be tempted to go after that 31 hertz content, but that's not what they're really asking for. I might give informed consent and do some psychoeducation around it. Maybe they'll want to trade it down. Maybe they won't. They can always go talk to some other practitioner, some naturopath, some functional doctor. They can change their lifestyle. They can do a lot of other things. But ultimately, it's their choice. I'm not a train the brain to look pretty. I provide psychoeducation, informed consent, and then I do what they ask me to do. Does that make sense?
I like it. And the informed consent is regarding that some people think that you can possibly lose drive if you get rid of those frequencies.
Oh, I don't think that's the case here at all. I just think it's like, why are they here? And and the reality is, with this kind of case, they're primarily here for hypervigilance and reactivity. Now, after we resolve that, if they kind of feel a little bit of extra courage and they go, there's other issues that might relate to attention or mood, I might think about this 31 hertz finding a little bit more aggressively. Based on the location, it might be messing with mood, and it could be messing with attention. Maybe it's worth going after if they have the desire for that. You also are going to provide neurocognitive testing that has neurocorrelates. I like to give out the 1020 CNC by Thomas Brownback, or I like to give out the Crayos Cognitive Test by Cambridge University. And those will correlate complaint to regional location, which is extremely useful because it can help you figure out which findings are the most problematic based on their request complaint. They're wanting you to fix these set of symptoms. Okay, which neuromarker is that? Well, if you don't know off the top of your head from just like lots of study and experience, go to the CNC 1020, go to some sort of neurocognitive test that has neurocorrelates and have it help you figure out which one. There's also a huge amount of drama reducing factor to that, because other practitioners in the area and other physicians that might be critical towards what you're doing, once they see those neurocorrelates, they're all on board. They don't care. They're like, oh, they see the merit of the qEEG. As soon as they see neurocorrelates, they're on board. Like even the strongest critics will kind of bite their tongue if they see neurocorrelates.
Well, radar gets to the point here. What would you recommend training for this person?
This person did get alpha down training, like Ruth Laney's protocol, and this is about 12 sessions afterwards, I believe. And so the asymmetry is significantly reduced. relative to the first one. So we reduced like 70-80% of the asymmetry just in about a dozen sessions. And their hypervigilance and reactivity was noted using, I think, the PCL5, which is like a PTSD questionnaire, and they went from like severe to subclinical.
Would you do alpha down at PZ if they had T6 finding more so?
I just train at PZ. I just follow Ruth Landis's research. It works great. Yeah.
But even for if that T6 or even if that alpha is sort of clustered at that T6 or
yeah, it will be clustered at it'll be clustered at T6 or P4 or both, and I will train it at PZ every time, and it will respond. We graduate maybe 50 plus people a year.
Yeah, that's interesting because I think that Jay told me that he sees that alpha down renormalizing after treatment, but you're seeing it go down. And so I need to collect my thoughts.
We're just seeing, so when you train alpha down at PZ, it improves phase, coherence, symmetry, amplitude, peak frequency, everything. All I did was train it down at PZ with a boring feedback of beeps.
Yeah.
And it fixes a lot of things I didn't tell it about. That's just a reset.
You do that for hypervigilant patients. You use the auditory tones because you're worried about high beta or something like that going up.
Alpha is sort of bimodal. It's either on or it's off. And so I use sort of a bimodal feedback. I use a boring feedback because I don't need it to be like hyper dynamic, because alpha is not hyper dynamic. It just turns on or turns off. So I want feedback that turns on or turns off. Usually I want something hyper dynamic, but not with alpha.
All right, everyone. That's Brain Bar episode 1. Thank you, Joshua. Thank you, Anthony. Thank you for everybody showing up in chat. We're going to take a week off. We're going to digest everything here. Pete at neuronoodle.com. Please send your feedback. We want to get this right. And then tomorrow, Jay Gunkelman, the man who's read over 500,000 brain scans, will cold read the same scan with zero knowledge of what happened tonight. Same brain, different eyes. Hit subscribe and the bell so you don't miss it. See you in 2 weeks. The bar is closed. You don't have to go home, but you can't stay here.
Love it.
Joshua, real quick, your URL and we'll split.
What's that?
Your website.
Oh, the qEEGcourses.com. Yep. Just that for neurofeedback training.
That's great.
All right. And then anything in the chats there, Anthony? I know you hate promoting yourself.
Yeah,
he's fun. He makes Facebook fun.
Yeah, nothing. I mean, there's always something exciting. So, but anyway, so.
All right, everybody. See you in a couple weeks. Hey, Joshua, seriously, this is awesome.
Thank you. I'm hoping it works.
Very enjoyable. Thank you.
Thank you. We'll get better at it.
Well, hey, you got to start somewhere, right? All right, everybody.
Good feedback in the chat. All right. I think he was getting good reviews in the chat as well. Fascinating.
Good. That's good. That's good.
Well, it only cost me 20 a pop. All right, everybody. Take care.
Okay. All right, thanks, everyone.
Great job. Bye-bye.